Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. So steps to find the volume by the disk method. Number one, graph the region. Please don't skip that step. Draw a representative rectangle perpendicular to the axis of revolution. This will also help you to know if you're going to integrate with respect to X or Y. We haven't looked at a problem where we're going to integrate with respect to Y, but we will right now. Your representative rectangle is your clue, because if your representative rectangle is oriented vertically, then the base, the thickness of that disk is dx. So you know it's a dx problem. So that means that when you find your radius, if the representative rectangle is oriented vertically, you're finding a function of x's for your radius. The formula for your radius will have x's in it. On the other hand, if it's oriented horizontally, it's a dy problem. So your radius will have y's in it. Okay, now what do I mean by the radius r of x? That's the distance from the axis of revolution to the other side of the region, to the function, to the curve. Then we have to find our bounds and integrate, and the formula looks like this. If it's a dx formula, it looks exactly the same, but just with y's in it if it's a dy formula. Okay, this one says find the volume of the solid generated by revolving the region between the parabola x equals y squared plus 1 and the line x equals 3 about the line x equals 3. First, let's go ahead and start graphing. So the line x equals 3 is easy enough to graph. Let's do that. Is it vertical or horizontal? Vertical line, that's right. And now let's graph x equals y squared plus 1. So we know that's a parabola. Not only did they tell us, but we can see the highest power is 2. It's going to be very similar to the graph of y equals x squared plus 1, right? Y equals x squared plus 1 is a parabola shifted up, but we have switched all the x's and y's. So instead, it's going to be, instead of an upward opening parabola, which way is this guy going to open? To the right, yes. For example, and you can confirm this by plugging in if you're not sure, I think it goes through the point 1, 0. Am I right? If you plug in, we get 1 equals 0 squared plus 1. Yes, I am correct. 2, 1. Yes, 2, 1. And 2, negative 1. And I'm going to shade the region that's between the parabola and the line. We know that intersection points are important. In this case, how would we find this intersection point here? So we know that x is always equal to y squared plus 1, but x is 3 along that vertical line. So replacing x with 3, then we're going to get 2 equals y squared, which means y is equal to what? Positive or negative square root of 2. So we actually found both the intersection points. We have 3 root 2 and we have 3 negative root 2. What we just did was graph our region, including intersection point. Now we need to do step 2, draw our representative rectangle perpendicular to the axis of revolution. X equals 3. So I'm going to draw in my representative rectangle horizontally. Rectangle is horizontally oriented. Find r of y. Okay, and remember, it also says in step 3, these are the distances between the axis of revolution and the graph. What I mean by that is the height of the representative rectangle. When you have a horizontal rectangle, I'm going to put height in quotes because obviously it's sideways, is right x value minus left x value. So at any random y value, some point here, it's going to have the y coordinate. What would the x coordinate be corresponding to that? 3. Good. And now how about at the top of the, or left side of our sideways rectangle, what would the coordinates be there? The y is just going to be y, just like when we did vertically, we just let it be x. And then the x is going to be equal to y squared plus 1. So when I say right x value minus left x value, I have to do the right x value is 3 in this case, minus the left x value is y squared plus 1. So that means that we have r of y is equal to 3 minus y squared minus 1, or 2 minus y squared. All right, so we have completed step 3. Now we're going on to step 4. Find the bounds and plug into the integral. Since we have an r of y problem, we're integrating with respect to y. So we are going to say volume equals the integral from, this is going to be a dy. It's going to have a pi. You can put it out front. And now we need to write our r of y squared inside here. So 2 minus y squared squared. Now, since it's a dy problem, the bounds are y value. So we have to go from the bottom y value to the top. What would the lower bound be? Negative square root of 2. See how that's the lowest point on the region? And then the highest point has a y value of positive square root of 2. All right, so this is equal to pi times the integral from negative root 2 to root 2 of, and what's the common error that we're going to avoid here? Yeah, distributing the exponent, exactly. So instead we're going to FOIL it out, right? So there's also a pattern you can follow when you square a binomial. It's a little rhyme. Square the first, square the last, multiply together, and double up fast. Square the first means squaring the 2, which is 4. Squaring the last means squaring negative y squared, which gives you positive y to the 4th. Multiply together and double up fast means 2 times negative y squared is negative 2y squared. Double that and you get negative 4y squared. So now we're going to integrate. We're going to have 4y minus 4y cubed over 3 plus y to the 5th over 5, evaluated from negative root 2 to root 2. And the rest is arithmetic. So we have pi. We have 4 root 2 minus root 2 cubed is 2 root 2. So that's going to be 8 root 2 over 3 plus root 2 to the 5th power is going to be 4 root 2 over 5. Okay, we're going to subtract from that, parenthesis, negative 4 root 2 plus 8 root 2 over 3 minus 4 root 2 over 5. So 64 pi root 2 over 15. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.